Welcome back. Today we're going to take a look at some more properties of exponents. So we're going to be learning three new rules, but basically these three rules are basically the same rule. So we got rule 5, says a power of a power. So if you take a power and raise it to another power, what you do is you multiply the exponents. It's kind of like the Schroeder property of exponents. So you got an exponent on the outside of your parentheses, so you multiply by all the exponents on the inside. So you get x to the AB. Basically, this is the same rule for 6 and 7, just written differently. 6 says you can use this rule when you have a product. So if you imagine, the exponents on the inside on the x's are 1 and the y is 1. And then you take a times 1, a times 1, you get x to the a, y to the a. Same thing if it was a quotient or using division. The exponents on these variables are 1. Take the exponent on the outside, like the Schroeder property, and distribute that to all the exponents on the inside. So this is the rules, these three rules that we're going to be working on today, but you might have to use some of the rules that you learned yesterday as well. So let's look at these examples. It says simplify the expression below. So this first one, we're going to have to use the second one that we learned today about. This is a product of a power. So what I want to do is I want to take the exponent on the outside of my parentheses, and I'm going to multiply by all the exponents on the inside. Okay? Now there is an exponent that we don't see. There's an exponent on the 2. The exponent on the 2 is a 1, so we can't forget about it. So we also got to take that 3 times the 1. So we got 2 to the third power, because 1 times 3. And then we got x to the 9th power, because 3 times 3. And then we got y to the 3 times -2 is -6. So there's my answer. But it says to simplify the answer. So this answer is not simplified for 2 reasons. The first one is this. 2 to the third power is 2 times 2 times 2, which is 8. X to the 9th, can't do anything with that, so x to the 9th is x to the 9th. But remember, we can't have negative exponents in our final answer. So what we're going to do is we're going to think of this as a fraction. This expression was a fraction, or b over 1. What has to the negative exponent? The y does. What does the negative exponent do? It relocates the power. So it's going to move it down to the denominator of this. And then when you move it, you change the exponent from negative to positive. So there's my simplified answer. 8x to the 9th, y to the 6th. All right, let's look at B. Well, B, whenever you have exponents on the outside, you always want to get rid of those first before you do anything else. Okay? So we got this 2 right here on the outside. So we're going to have to do it like we did A. So I'm going to take this 2 and multiply by all the exponents on the inside. So this gives me x to the 4th, y to the 6th. And I'm multiplying that by this expression, x to the 5th, y to the 6th. So we use the second rule that we learned today, the product of a power. So now we're going to use the rule that we learned yesterday. When you multiply powers of the same base, you add the exponents. So we can take x to the 4th times x to the 5th, which will give us x to the 9th. It's 5 plus 4 is 9. And then I can take y to the 6th times y to the 6th. That'll give me y to the 12th. So there's my simplified answer. X to the 9th, y to the 12th. And then last, let's do C. Well, C, you can do a couple of different ways. You can go ahead and distribute the 2 on the outside, the exponent of 2 on the outside to all the exponents on the inside, and then reduce. Or it would be easier to actually reduce inside of parentheses before we distribute the 2. So let's simplify inside the expression first. Well, 3 over 6, if you had the fraction 3 over 6, that would reduce down to 1/2, right? All right, how many x's can you take away from both the top and bottom? You got x squared on top, x to the third on bottom. So what's the most amount of x's you can take away from both the top and the bottom? 2 of them. So I'm going to take all the x's away from the top. That means I'm only left with 1 x on the bottom. So I got x to the first on the bottom. Now let's do the same with y's. What's the most amount of y's I can take from the top and the bottom? 5 of them. I'm going to take all 5 away from the bottom. If I take 5 away from the top, and there were 7 up there, now I'm left with over 2 of them. So now we get this. 1y squared over 2x to the first. That quantity is squared. Nothing can be reduced on the inside. So now, let's take our exponent on the outside and multiply it by all of the exponents on the inside. Remember, this 1 and the 2 have an exponent. The exponent on them, the 1. So we get 1 squared times y to the 4th over 2 squared times x to the 2nd. And then, can we simplify anything? Yes. 1 squared is 1. And then 1 times y to the 4th is just y to the 4th. So the numerator just simplifies down to y to the 4th. And then 2 squared is 4. And then we got x squared. There's my simplified answer. So these are the types of problems you're going to be practicing today. I could throw on some problems from yesterday just as a review. So be aware of that.